Welcome to Podcast Learn and Fun. Let's start today's journey of learning. We've all probably wondered what happens to that beer or that glass of wine, after you drink it.
Right.
Turns out
Yeah.
there's a whole system in your body that's, dedicated to breaking down alcohol. And it all starts with a family of enzymes.
Right.
Called alcohol dehydrogenase.
Yes.
Or ADH.
Yeah, it's like a specialized cleanup crew working mainly in your liver, but also present in other tissues.
Okay.
And ADH kicks off this two-step process
Okay.
to transform alcohol into something your body can handle.
So it's not like alcohol just like magically disappears from our bloodstream. There's like actual chemistry involved.
Absolutely.
Uh-huh.
First, ADH converts the ethanol in your drink into a substance called acetaldehyde.
Okay.
Now, acetaldehyde is actually quite toxic.
Okay.
It's the main culprit behind those nasty hangover symptoms.
So that's what causes the pounding headache and just like feeling of regret.
Right.
But our bodies don't just leave us with that toxic stuff, right?
Nope. That's where the second part of the process comes in. Another enzyme called ALDH takes over
Okay.
and converts that toxic acetaldehyde into something much less harmful, acetic acid and acetic acid. Your body can easily use that for energy or further break it down into carbon dioxide and water.
So it's a tag team effort
Yeah,
with ADH and ALDH working together to detoxify the alcohol.
exactly.
But what I find fascinating is that this whole process happens at the microscopic level.
Right.
Involving, these tiny molecules like NAD plus sound.
Right.
What exactly is NAD plus SAD and why is it so important in this process?
Okay. Think of NAD Plus as a tiny taxi service operating within your cells. These taxis pick up electrons from one part of a chemical reaction and drop them off somewhere else. So in the case of alcohol metabolism, NAD Plus is crucial for both ADH and ALDH to do their jobs. Without enough NAD Plus, the whole process gets backed up, and you end up with a buildup of acetaldehyde, hence the hangover.
Oh, wow.
But NAD Plus isn't just involved in alcohol breakdown. It plays a vital role in numerous other metabolic processes throughout your body, impacting everything from energy production to DNA repair.
Wow. So these tiny little molecules are essential for keeping our bodies running smoothly.
But here's where it gets really mind-blowing to me. I heard that ADH actually uses quantum mechanics to break down alcohol. That sounds like something straight out of a sci-fi movie.
It might sound unbelievable, but it's true.
Yeah.
Scientists have discovered that ADH uses a phenomenon called quantum tunneling to speed up the breakdown of alcohol.
Okay, break that down for me. Quantum tunneling.
Imagine a tiny particle, like an electron, trying to get through a wall. In the classical world, it would need enough energy to climb over the wall.
Right.
But in the quantum world,
Yeah.
the particle can sometimes tunnel right through the wall,
What?
even if it doesn't have enough energy to go over it.
So it's like the enzyme is taking a shortcut through reality.
Exactly.
That's incredible. And this tunneling effect allows ADH to work much faster than it would otherwise. It's a remarkable example of how quantum mechanics plays a role in the everyday workings of our bodies.
Mind-blowing.
Yeah.
But now I'm curious. If everyone has ADH, why do some people seem to handle alcohol better than others?
That's a great question. And it leads us to the fascinating world of genetics. Not all ADH is created equal. We all have slightly different versions of the ADH gene called gene variants.
Right.
These variants can affect how efficiently your ADH enzymes work,
Okay.
which in turn influences how quickly you metabolize alcohol.
So some people might naturally break down alcohol faster than others,
Precisely.
thanks to their genes.
And this can have a significant impact on your experience with alcohol. For example, individuals with certain gene variants might be able to drink more without feeling as intoxicated, while others might experience those unpleasant effects much more quickly.
Interesting. So it's not just about how much you drink, but also about your individual genetic makeup.
Absolutely. Your overall health, body size, even what you've eaten that day. Oh, wow.
Can influence how your body processes alcohol.
Wow.
It's a complex interplay of factors.
Yeah.
But understanding how ADH works
Yeah.
and the role of genetics can give us valuable insights into why people respond to alcohol differently.
This is all so fascinating. I'm starting to realize that there's a whole lot more to alcohol metabolism than I ever imagined.
There's always more to learn.
Yeah.
And that's what makes science so exciting.
Yeah.
But for now, let's take a deeper look at these gene variants and how they can impact your individual response to alcohol. You know how some people get flushed, and just feel unwell after just a sip of alcohol?
Yeah.
That's often due to a gene variant that makes their ALDH, that second enzyme we talked about, less efficient.
So they can't break down that toxic acetaldehyde as quickly,
Right.
leading to a buildup in their system. Exactly. This buildup can cause a range of unpleasant effects, including facial flushing, nausea, and a rapid heartbeat. It's actually quite common in some East Asian populations. And it's a great example of how our genes can directly influence our response to alcohol.
It's fascinating how these tiny variations in our DNA can have such noticeable effects. But I'm also thinking about, those people who seem to be able to drink everybody under the table.
Right.
Are they just genetically gifted with super efficient enzymes?
Well, there are gene variants associated with faster alcohol metabolism. People with these variants might have ADH enzymes that work overtime, rapidly breaking down alcohol into acetaldehyde.
So they might not feel the effects of alcohol as quickly.
That's right. And while it might seem like a superpower, it's important to remember that even if you metabolize alcohol quickly, excessive drinking can still lead to health problems in the long run.
Yeah, it's a good reminder that our genes don't give us a free pass to overindulge. But thinking about these different gene variants makes me wonder, could this knowledge be used to personalize health advice related to alcohol?
That's a really interesting question, and it's an area of ongoing research. Scientists are exploring the potential for using genetic information to assess individual risk for alcohol-related problems and to develop personalized recommendations for alcohol consumption.
That would be amazing. Imagine getting tailored advice based on your own unique genetic makeup. It could revolutionize how we approach alcohol consumption and help people make, more informed choices. But what about the other side of the coin? What happens when people drink heavily over a long period?
Long-term heavy drinking can actually increase the amount of ADH in your liver.
Right.
This might seem like a good thing. More enzymes to break down alcohol, right? But unfortunately, it's not that simple.
I have a feeling there's a but coming.
You're right. While having more ADH might initially lead to faster alcohol breakdown, remember that first step involves converting ethanol into acetaldehyde, which is toxic. So increased ADH can actually lead to a buildup of acetaldehyde, even if you're not drinking at the moment.
Oh, wow.
This can damage the liver and potentially contribute to a range of health problems.
So it's a bit of a double-edged sword.
Right.
Our bodies try to adapt to heavy alcohol consumption by producing more ADH.
Right.
But this adaptation can end up causing more harm than good.
Exactly. And this highlights the complexity of alcohol metabolism and the importance of understanding both the short-term and long-term effects of alcohol in our bodies. But, let's not forget about another crucial aspect of alcohol consumption.
Okay.
Its potential interaction with medications. This is something everyone should be aware of.
Right. We've talked a lot about how alcohol is metabolized, but what happens when it mixes with, other substances in our bodies like medications?
Alcohol can interact with a wide range of medications, sometimes with serious consequences. For example, mixing alcohol with certain painkillers can increase the risk of stomach bleeding, or it can intensify the sedative effects of certain anxiety medications.
That sounds pretty scary. So how does ADH fit into all of this?
Well, remember that ADH isn't just responsible for breaking down ethanol. It can also metabolize other types of alcohol.
Okay.
Some medications contain alcohol as an ingredient,
Mm-hmm.
or they're metabolized into compounds that ADH recognizes.
So if you're taking those medications and drinking alcohol at the same time, you're essentially giving your ADH double duty,
Right.
which could create problems.
Precisely. It can create a bottleneck in the system, leading to a buildup of both the medication and alcohol in your bloodstream. This can increase the risk of side effects, reduce the effectiveness of the medication, or even lead to dangerous interactions.
That's a really important point. It's not just about how alcohol makes you feel, but how it can interact with other substances in your body.
Absolutely. And it highlights the importance of talking to your doctor or pharmacist about potential interactions between alcohol and any medications you're taking. They can provide personalized guidance based on your individual health conditions and medication regimen.
That's great advice.
Yeah.
So we've learned about ADH, ALDH, gene variants, long-term effects, and even medication interactions. What's the biggest takeaway you'd like our listeners to remember about alcohol and our bodies?
I think the key message is that alcohol metabolism is a complex and individualized process. Your genes, your overall health, and even your lifestyle choices all play a role in how your body handles alcohol. What might be fine for one person could be risky for another.
Yeah, it's a reminder that we all need to be mindful of our alcohol consumption. and make choices that support our well-being.
Exactly. And with that, I think we've covered a lot of ground today.
Yeah, it really is amazing how much is going on inside our bodies when we drink alcohol. We've talked about enzymes, genes, and even quantum mechanics. But I'm curious, like, what can we actually do with all this knowledge? How can we use it to make healthier choices?
That's the million-dollar question, isn't it? Knowledge is power. And understanding how alcohol affects us individually can empower us to make informed decisions.
So it's not just about saying drink responsibly, but actually, like, understanding what responsible drinking means for each of us.
Precisely. For some people, responsible drinking might mean limiting their intake to, a certain number of drinks per week. For others, it might mean avoiding alcohol altogether, especially if they're taking certain medications or have a family history of alcohol-related problems.
It's about recognizing that one size doesn't fit all when it comes to alcohol.
Absolutely. And there are steps we can all take to minimize the negative effects of alcohol. Staying hydrated, eating before and during drinking, and pacing yourself can make a big difference.
Those are great practical tips. But I'm also thinking about the bigger picture. We've touched on the potential for personalized health advice based on genetics. Do you think that's the future of alcohol consumption?
It's certainly a possibility. As our understanding of genetics and alcohol metabolism advances, we might see a day when people can get their genes tested to assess their individual risk for alcohol-related problems and receive tailored recommendations for safe consumption.
That would be incredible. It could revolutionize how we approach alcohol
Yeah.
and help people make choices that truly align with their health goals.
Imagine a world where people could understand their own limits and make informed decisions based on their unique genetic makeup. It could significantly reduce the incidence of alcohol-related health issues and promote overall well-being.
It's an exciting vision for the future. But even without genetic testing, I think this conversation has given us all a lot to think about.
I agree. From the intricate workings of enzymes to the powerful influence of our genes, alcohol metabolism is a fascinating and complex process. By understanding the science behind it, we can empower ourselves to make healthier choices and enjoy alcohol responsibly.
Well said. Thank you for listening to Podcast Learn and Fun. If you like our videos, please subscribe, click the like button, comment, and share. See you next time.